derivative of sine x. I'll just show you how sine x is done, and the other trig functions are pretty much similar. So I'll just write down the result for that. Okay? You don't have to be able to reproduce the proof, but always when you have a proof, it's good to look at it once or twice just to see how things work. You know, most of your engineers, and what's the job of the engineer? You're curious to know how things work, right? So I'm actually showing you how things work internally. Rather than just saying the derivative of sine is something, I want to show you why it is. One formula you need for handling sine of x plus h is a sine sum of the angles formula, angle sum formula for sine. This is sine A cosine B plus cosine A sine B. So if I apply that to here, here, and then since these two terms have sine x in common, I want to factor the sine x out. So sine x is factored, and you get cosine h minus 1 divided by h. I'm going to split off this one as a separate cosine x sine h over h. When I take h to 0, really the ones that do change their values is here and that one, right? Okay, one of them we know. What's the limit of this one? This goes to 1. Sine x over x, where x goes to 0, is 1, that we already know. How about this limit? Well, that one we will have to calculate separately. And to do that limit, you need to use conjugate. Okay? So cosine h minus 1, you multiply cosine h plus 1 top to bottom, so that this thing turns into cosine squared of h minus 1 over h times cosine h plus 1, limit h equals to 0. And if you use the fact that 1 is same as sine squared plus cosine squared will cancel, sine squared will survive, so you end up with negative sine squared of h over h times cosine h plus 1, limit h going to 0. And then sine h over h goes to 1, that we know, but there's an extra negative sign that's remaining on top, right? What's sine of 0? What's sine of 0? 0, right? What's cosine of 0? 1. So what's this value?
0.
So that, by looking at that, we see that this converges to 0, whereas this one converges to 1. Therefore, the answer is sine of x times 0 plus cosine of x times 1, which ends up being cosine of x. Now you can do a calculation very similar to this using the cosine sum angle sum formula for the cosine. So if you wanted the derivative of cosine of x, in order to calculate this derivative, you need to make use of the cosine angle sum formula, which is, write it here, cosine of A plus B is cosine A, cosine B, minus sine A, sine B. And I don't want to bore everyone with another proof. I just want to say that this minus somehow carries over at the end of the proof, and you end up with minus sine x. So that's just some fact I'm throwing out there for you to memorize. Okay? So derivative of sine is what? Cosine. Derivative of cosine is negative sine. That's the thing you have to do. Now let me add to this the derivative of an exponential function. Okay. Derivative of a to the x. What is a to the x prime? Well, that's limit h going to 0 of a to x plus h minus a to the x over h. Always just take the original function, replace x by x plus h, and subtract the original function, divide by h. That's the definition of the derivative. Right? And therefore, we get, well, this is a to the x times a to the h minus a to the x over h. So that gives you a to the x times a to the h minus 1 over h. So it remains to be, what's remaining for us to know is what is this thing? See, a to the x is just some constant multiple that's fixed, right? What we need to know is what happens to this second part. Now, if you think about it, if I say f of x is equal to a to the x, then f prime of 0 is exactly this thing that's attached, okay? I can show you that by writing down the explicit limit h going to 0. What is this? You have to replace, well, the formula is f prime of 0 is f of 0 plus h minus f of 0 over h, isn't it? That's the definition. And this is like evaluating the function at h, so you replace x by h, which gives you a to the h power. What's f of 0? Hmm? 1? Who said that? Oh, good. Okay, so isn't that exactly this, right? Okay, so what does that mean? Well, let's go to the graph of a to the x, y equals to a to the x. A to the x, if a is bigger than 1, the graph looks like this. If a is between 0 and 1, it actually is decreasing, but let's just think about this. What's the meaning of f prime 0? When I said meaning of a derivative, you should think what? slope of the tangent or rate of change, those two. So f prime of 0 means slope of what? Slope of the tangent at 0. So you think about x equal to 0, the location where x is equal to 0 is right here. And we have to draw a tangent line. And the slope of this line that I just drew is this quantity, this one. Okay. All right, so what that means is, first of all, that this does converge. It's not just some fictitious element here. We do know that because we are able to draw this tangent line to the exponential function without any trouble, we can definitely know that this has some limit. Okay, so there is this limit, and we can just finish off this calculation and say this should be a to the x times some mysterious number, which is really the derivative of the function at 0. So that we can just write it like that and think of this as a placeholder for now. Okay. Now this is the next one is when we first think about the natural number e. Okay. So we're going to figure this out later after we do the chain rule, something called the chain rule. For now, this is some mysterious number. But instead of obtaining this goal of finding the derivative of a to the x, we're going to settle for something less for now. And then in later lectures, I'm going to show you the actual derivative of a to the x. So the lesser result that we can get is, think about various values of a. Think about various values of a. If a is big, then it grows very fast, right? If a is close to 1, like 1.1, it gradually grows, right? So somewhere in between, can you think of a number, a, which is just right so that the slope is exactly 1? Something like that could happen, right? There should be something like that, right? And that number is called the natural number e. So natural number e, which later can be computed as 2.7182818, and then so on and so on. Right? That number has the property that if you compute e to the h minus 1 over h, it gives you 1. So that if you differentiate e to the x, it's just e to the x times this thing, which is 1. So what happens? The derivative of e to the x is same as e to the x. That is what we call the natural number e. Okay. So the important formula that we obtained after this discussion is not the whole thing. It's rather derivative of e to the x and e to the x prime is x. Okay, now let's summarize our results today. We learned a lot today. So all the rules we found. Number 1, x to the n prime is nx to the n minus 1, the power rule. Number 2, x prime is 1. Number 3, any constant differentiates to 1. Number 4, differentiates to 0, thank you. Square root of x differentiates to 1 over 2 radical x. Number 5, sine x differentiates to cosine x. Number 6, cosine x differentiates to negative sine x. Number 7, what's he saying? Yeah, e to the x differentiates to e to the x. And in addition to some list of derivatives of functions, we have the linearity, which says, well, it's two things. Constant should be pulled out and differentiated. And if you have sum or addition or subtraction, you can differentiate separately. Whereas this is not true for multiplication. If you want to handle product of functions, you must obey is the strong word here, the product rule, which says if you have two functions multiplied, you differentiate the first, leave the second, leave the first, differentiate the second. Those are the basic rules.